Welcome to our Yaka Digital Network videos. Take a look at this aerial view of London. If a live event, like a major football match, is happening right there in the city, how can the video reach a living room all the way in Africa? Specifically, how does it arrive instantly on a television screen down here, in the bustling center of Kampala, Uganda? This diagram shows our core physical problem. The Earth is curved, but radio signals, which carry our television broadcasts and phone calls, travel in strict straight lines. They cannot bend around the planet on their own, and they cannot travel through the solid ground. Because of this barrier, a signal from Europe gets blocked by the curve of the Earth long before it ever reaches Uganda. To connect the two, we need a way to go above the ground. Imagine you and a friend are blocked by a tall, solid brick wall like you see on screen here. How could you send a light signal from your flashlight over to the other side? If you place a mirror high above the wall, you can shine your light up at it, and the mirror will bounce that exact beam sharply down to your friend on the other side. That simple trick of bouncing a signal off a high-altitude mirror is exactly how we solve the Earth's curvature problem. It is the basic mechanism for all modern global communication. In space, a satellite is simply any object that travels in a steady, repeating path, or orbit, around a larger planet. Earth has one natural satellite that has done this for billions of years, the Moon. But look at this video. This is an artificial satellite. It is a machine engineered by humans, equipped with sensors, powered by large solar panels, and carried up into space by a rocket. While the Moon is our only natural companion, humans have launched thousands of these artificial machines. They operate as our high-tech space mirrors. Let's see how data travels in this animated diagram. First, a ground station in Africa beams a strong radio signal up into space. We call this initial upward journey an uplink. The satellite acts as an active relay station. It catches that uplink signal and gives it a powerful boost so the data doesn't fade away into space. Then, the satellite beams that newly strengthened signal back down to a completely different location on Earth. We call this returning path a downlink. This entire trip covers tens of thousands of kilometers, up and back, yet the complete sequence finishes in a fraction of a second. The uplink and downlink sequence creates an invisible bridge in the sky, connecting any 2 points on the globe instantly. Take a look at this standard white satellite dish mounted on a roof. If the satellite in space is constantly moving around the Earth, why does this dish stay permanently fixed in one single direction? This satellite is traveling at the exact same speed the Earth rotates, completing one full circle every 24 hours. Because the planet and satellite move in perfect harmony, the machine stays locked over one specific spot. This creates a geostationary orbit. It is why your dish never has to move. The satellite it is talking to is always exactly where the dish is pointing. Here is a quick question on screen. True or false? Do satellites stay in that fixed position because they are hanging by cables in space? The answer is false. As this animation shows, there are no strings attached. A satellite stays in orbit because it is moving horizontally at an incredibly high speed. That fast-forward motion perfectly balances the downward pull of Earth's gravity, keeping it falling in a perpetual curve around the planet. It is precise physics and extreme speed that keeps our communication networks constantly aligned. While television broadcasts are a major use of this technology, these machines also provide data for our daily survival and movement. Look at this map on a smartphone screen. A separate satellite network sends precise location data down to Earth to create the GPS system. This enables navigation apps to guide local transport, like a boda weaving through busy streets. And in this image of a farm, we see another vital application. Specialized weather satellites monitor cloud formations and temperature patterns from above, giving farmers the advanced warnings they need to track incoming rain. Watching an international football match, finding a quick route across town, deciding when to plant your crops, you are relying on space technology. Our sky is filled with thousands of artificial relays, seamlessly catching uplinks and projecting downlinks to bypass the physical curve of the Earth. This invisible web of signals is the quiet foundation of our modern, connected world. You can watch more videos for all classes here, and get all content at www.yaka.cc.